Very good morning to all. Today's topic is principle of wireless sensor networks. So we know that general networking, computer networks, how it is communicating with the application to application to the OSLAs, 7 OSLAs, starting from application to physical and medium, and from medium to physical, and from physical to applications, how the packets are transferring from the source to destinations. We know that. Similar to that, before going to design any sensor networks or before designing any ad hoc networks, that is infrastructure-less networks, we need to follow certain principles and what are the parameters to be considered before designing. That things we are going to discuss now. So the first, wireless sensor networks or networks of autonomous sensor nodes that are capable of collecting, processing, and transmitting data wirelessly. So we know that sensor networks are deployed in some remote locations, and we are operating at our comfort places, comfort zones. So we need to consider the parameters. The parameters are the resource constraints, communications, data aggregation, routing, security, data processing, and application specific functionality. So first thing is resource constraints. So this is the major parameter we need to consider. That is, the sensor networks operates with the power backups and the implementation cost we have to consider. So the major feature is the low cost and low power of wireless sensor networks. So most of the time, sensor networks depend on the battery power backups. Even though it is deployed at some remote locations, we need to consider some other sources of power backups through energy scavenging that we will discuss in the later classes. What are the types of energy scavenging available for sensor networks? And the second parameter is communication. So here the RF transmission is used. And one more thing is the nodes in the network should cooperate. So number of nodes in a clusters, a number of clusters that we call it as entire network. So we know that in sensor network, there are a number of clusters are operating. So inside a cluster, a number of nodes are communicating between the nodes and between the clusters. So we know the parameters of the homogeneous and heterogeneous nodes. So the sensor nodes follow these parameters similarly. Then we call it as the homogeneous networks. And heterogeneous networks, we know that there is some deviations in the parameters, that is sleep schedules, like lifetime wake up schedules, and some other schedules, synchronization of packets, transmission of packets. All this informations are not similar to one among the nodes, then we call it as a heterogeneous nodes. Then third parameter is the data aggregation. So in data aggregations, it performs the aggregation of data before transmitting. So we are dealing the number of sensor nodes in terms of clusters. So for example, in a cluster 1, there is a 10 number of sensor nodes operating. So one cluster node is giving a cluster head. So that node is taking responsibility among the entire network in the cluster. So any data that is coming from the 8 to 9 nodes, the head sensor node is aggregating the data before taking to the transmitting. So in this way, all the clusters will work together to cooperate with the sensor node and transmitting data to the user. Right. Then next parameter is routing. We know that routing to find the best and the shortest path to reach the destination. So here also the sensor node has to find and to depend on some routing algorithms to find the shortest and efficient path to take the packets or to take the information from source to destinations. Then security. So security plays a vital role in sensor networks to protect from some external attacks, and how far the networks is protects to any kind of vulnerable attacks and all. And this is on parameter. And data processing. So here filtering and compressions of data is carrying out before transmitting. The data aggregation has been taken place, and also filtering and processing of data has to be done, and then only the data is ready for transmissions. And also the last parameter is we can call it as the application specific functionalities. So in what purpose and what application point of view we are designing our nodes, that is very important thing. So that we need to consider before selecting the nodes. So once we have confidence with all these parameters, then we move on to the designing of sensor networks to the proper way of the network and the node architectures. So first we will discuss the introductions part of sensor networks. So we know that a sensor device that detects and responds to some type of inputs from physical environment. So the inputs can be the light, heat, motions, moisture, pressure, or any number of inputs. The output is to be converted into human readable formats. That is, the non-analytical quantity has to be converted into analytical quantity. So this is the exact sensor node architecture. So here you have 5 components. The components are the controller module, memory module, communication module, sensing module, and power supply module. So these are all the 5 components of a sensor node architecture. So this component is going to form as a sensor node, and this node is going to deploy at some remote locations, and it is functioning some operations and transmitting some informations to the user data. Then these are all the brief discussions on the different types of components inside the nodes. So here the sensor nodes are having the first components are controller. So it processes all the relevant data, that is relevant informations, and communication devices. Here it is a transceiver is used to transmitting and receiving the data from and to the remote locations. And sensors, it plays a physical interfaces to the physical world. Memory, it stores the data and process and retrieve the data. So power supplies through batteries, we are charging and recharging from the environments. So a separate topic called energy scavenging is done in the battery side. An example, the best example, we can call it as solar cells.